Hello world, and welcome back. In this section, we are covering the in-person interview. What I'm going to share with you is what to expect during your hour-long interview, which you might have multiple times for any particular position. And then I'm also going to be covering my exciting whiteboard development environment. I call it the WDE. It's pretty cool. It's going to help you use and manage the whiteboard more effectively to capture the ideas and allow you to communicate more effectively with the manager when you are solving coding problems that you'll probably be asked in an interview. So let's get started. Now, the interview day. There's like 3 different classes of interviews that you might get. Let's say you are interviewing for a contract position, a CSG or contingent staff position. In these interviews, candidates typically meet with 3 interviewers, one-on-one, for each interview hour. And this is typical of most contract positions that you might be interviewing for. It's pretty simple, pretty straightforward, not very many people. Now, if you are interviewing for a vendor role, typically the interviews are a little different. The candidate will meet with 5 to 7 interviewers, one-on-one, each for I messed this up. Okay, I'm starting over. That's for a full-time interview. I do the vendor one last. Hello world, and welcome back. In this section, we are covering the in-person interview, where I'm going to help you understand what to expect when you go out for an interview. Also, I'm going to be covering the whiteboard development environment. It's my unique way of structuring the whiteboard so that you can keep track of your thoughts and the information that you've collected from the manager while you implement a solution to a coding exercise you're given. All right, let's get started with the first type of interview that you might go out on. This is a contract interview or a contingent staff position. In these interviews, they're not as difficult. You don't have as many managers that you're going to be... I'm going to rewind one more time. I can do this. Hello world, and welcome back. In this section, we are covering the in-person interview. We're going to be going over what to expect in your hour-long interviews when you meet with managers for a job you are interviewing for. Also, I'm going to be covering the whiteboard development environment. You can use this format, this way of structuring the whiteboard, to help you communicate better in the interview. As you are implementing your code, you can also have designated sessions for sections. Sections, blah blah gilulu, babbligadoo. One more time. Hello world, and welcome back. In this section, we are covering the in-person interview. We're going to be going over what to expect when you go out for an in-person interview and what the structure of the hour is going to be like. And I'll also be covering the whiteboard development environment, a way of structuring the whiteboard and placing content, placing the ideas, placing the information on the whiteboard to document what the manager has told you about the coding exercise that you'll be implementing. It's an effective way to help communicate and demonstrate that you have solid software development skills. So let's get started. Now, the interview day. What is your day going to be like? It depends. There are 3 types of interviews that you can go out on, meaning 3 types of positions or 3 types of employment that are most common. The first, contingent staff or a contract position. In these types of interviews, you'll typically meet with only 3 interviewers before your interview is done. One-on-one, each for 1 hour. Now, the next most common interview is a full-time interview. This is where a candidate typically meets with 5 to 7 interviewers, one-on-one for an hour each. But these are more involved than just a contingent staff position. Sometimes, if you get to the end, there might even be an as appropriate, someone who comes in and does a final decision to help decide whether or not you should be offered the position. Now, let me give you some context. These are the types of positions that were most popular at Microsoft. Google, Facebook, other companies might have slightly different ways of handling how a candidate gets decided upon when they are going to make the decision to extend an offer to that candidate. But needless to say, full-time interviews are more involved than contract interviews. The third type of interview is for a vendor position. This is where the candidate will meet with 3 to 5 interviewers, sometimes in a panel style where you're going to be asked multiple questions in front of 2 or 3 interviewers, kind of each one taking turns to query you about your background, about your history, and exercises to common interview questions, data structures and algorithms, and the fundamentals. So these 3 are the most common that you'll come across. But now let's move on to what the structure of the hour will be. Now, the first 15 minutes of the interview can be broken up into 3 sections. The first will be introductions. The manager will come and retrieve you from the lobby and walk you to their office. During that time, they'll probably ask you how you've been and how your interview day is going so far. But once you get into their office, the first thing that you should probably discuss, and the 2 of you should agree upon, is what type of job, what are the details, what is the information about what they're looking for, and how is that different than what is on the original job description. This is important because a lot of times recruiters, they might not know the nitty-gritty details of what the team is looking for. There might have even been a change in the requirements and what they're looking for between the time the job was published and the recruiter was sourcing for the position and the moment at which you come in for the interview. So the first 5 minutes after the introduction, the next 5 minutes will be spent and should be spent finding out more about what the position details are and what they're looking for. This is your opportunity to ask questions to get a better understanding of what's different from the job description and what the manager is able to tell you at that time. Now, this is important as well because what the manager is going to share with you will, 1, confirm what you already know, 2, will add to what you already know, and most importantly, it will help you map your past work experience to what the current job needs are so that for the rest of the interview, you can kind of have a better idea of what are you going to talk about and what matches up. And you'll have the opportunity to share that, especially when you're asked the most important interview question. Now, the third part of this 15 minutes, that's when you'll be answering the question, what have you been up to lately? Or tell me a little bit about yourself. or as I like to say, as I would hope every interviewer would start to ask every candidate, how did you contribute to the success of your most recent project? So this first 15 minutes, that's pretty much done. We covered the introduction, the opportunity for you to clarify what the job needs are and the job description is, and third, answering the question, how did you contribute to the success of your most recent project? Now, the next 40 minutes will be spent with technical questions. It'll be spent with whiteboard questions and coding questions. In a moment, we're going to go over the whiteboard development environment and how important that is to help you have a way to present your ideas. But let's continue with this 40 minutes. The technical questions that you'll be asked will hopefully be mapped well against your past work experience and what the job needs are. As we've stated in the last section, core patterns, mitigating risk, your answers should only cover what it is that you can speak about. Be prepared to say, I don't know. Have a dialogue with the manager. Be in a collaborative relationship with the manager where the two of you are examining and looking at the problem together. And don't treat the interview like a test. So, technical questions, it's there to authenticate you. The manager will choose specific questions for which you need to maintain a high level of trust. Do that, and by the end of the interview, the manager will have exactly what they need to make an appropriate decision about whether or not you will either mitigate the risk to the project success by being hired, or would increase the risk to the project success if they extended you an offer. Now, the whiteboard, it's so unfamiliar. A lot of candidates are not prepared to jump on the whiteboard and start coding up an example. So one of the strategies, one of the patterns that I recommend for candidates is you need to practice on a whiteboard. It's not enough just to open up a text editor and start coming up with an implementation to a particular problem. Now, I do recommend that in a pinch, you want to practice as much as you can, as often as you can, solving as many problems as you can, simple ones, focused on the fundamentals of data structures and algorithms, as well as searching algorithms. But a whiteboard, it's so critical. You want to be so comfortable at the whiteboard that if you make a mistake, it won't derail you. You want to be so comfortable that you know where to put certain types of information on the whiteboard so that it doesn't get cluttered. You want to do it so often that you get familiar with how large you should write on the whiteboard. Because I have this pretty funny story. When I began working at Volt and I started interviewing candidates, I had a small whiteboard. Maybe it was maybe 4 feet by 4 feet, just a tiny small whiteboard. And I noticed, oh man, the candidates were running out of space. And so I thought to myself, okay, I'll talk to our administrator. I'll find out if I can get a larger whiteboard, maybe an 8 foot by 4 foot whiteboard. And then that will solve all of our problems. The whiteboard comes, I mount it on the wall. The first candidate that comes in to write on the whiteboard, what happens? They write bigger. They actually scaled the text to match the size of the whiteboard. They still ran out of room, even though they had so much more space to write on. So practicing on the whiteboard so that you can use the space effectively is going to help you in the interview so that you don't run out of space. You'll be prepared to write at an appropriate size and give yourself enough room, but you'll only know how to do that if you practice. Whiteboards and solving coding problems, it's like oil and water. The practice is going to help you just go up without anxiety. You'll go up and feel comfortable writing on the whiteboard. Do that by practicing. Now, the last 5 minutes of the interview, that's spent with closing remarks. This is where you get the chance to ask any final questions about the project, and hopefully you don't ask, "How did I do in the interview?" That's a no-no. I've had candidates do that, even though their heart's in the right place and they're eager and they want to know if they did well. It's not the right time to do it because, like we talked about in the section, the goal of the interview, it's not to get a job, so you shouldn't be asking questions about whether or not you got the job. Don't use the last 5 minutes to do that. Instead, the last 5 minutes should be spent asking final questions about what is it going to take for the project to be successful. Why are they opening the position right now? How long has it been opened? What are the needs? Where does the manager see the appropriate candidate hitting the ground running when they get hired? These are the kind of things that you should be prepared to ask at the end of the interview. Keep the focus on the goal of the interview. Sorry, I meant to say keep the focus on the project's success. The questions that you ask will be geared toward, hey, what's it going to take for this project to be successful? I want to contribute, and the more I know, the better I can let you know, the manager, that my past work experience will help do this. It's kind of like the last play in a football game where it's all or nothing and you get one more chance to bring the focus back to, well, if your project needs this, I just happen to have this experience and it might bring value to your team. There are a few other questions that the manager might ask you at the end, more ambiguous questions like we've talked about in the managing ambiguity section. But we'll cover those strategies in a future session. But for now, just know the last 5 minutes of the interview are an opportunity for you to round the lake and just have a final opportunity for you to bring the attention back to your contributions in the past and how they might apply to what the team's needs are right now. All right, let's get into whiteboard strategies. This is a good section. This represents thousands of interviews and my observations for how candidates perform on a whiteboard and some of the patterns that will help you perform at your best in the interview. The first point I want to talk about is treating every coding problem like it was a small development project. Now, candidates, they'll tend to treat interview questions like trivia questions, where there's a right answer that they should be looking for. But managers, what they want to see is process. They want to see structure. They want to see what is your approach to these problems. And they want to understand how well do you manage ambiguity. By applying the stages of the software development lifecycle to every coding question you're asked, you're basically showing the manager, look, I understand everything that goes into creating a product, into creating a solution that can be used and that is valuable. That you understand the value of a clear statement, a clear set of requirements, a clear design, and a clear understanding of the analysis of the approach that you've chosen. That you understand the value of pseudocode and waiting to do your implementation until you've got the logic of what you're going to implement down. Also, that you understand the value of generating test cases, and that while you're doing your requirements gathering, you might actually use your test cases as a way to generate more questions to ask. And then last, being able to use a debug window to walk through your code. This is what we're about to cover. Now, you'll be stressing out in the interview, that is. You'll be up there on the whiteboard. You might be a little nervous. They'll ask you to write a function to remove the duplicate integers from an array of integers. Seems like a simple enough question, but the whiteboard development environment gives you the advantage of not having to store all of the details, all of the answers that the manager gave you in your head. What I find, and this happened to me in interviews before I started using this pattern, was that I'd think, okay, I'm going to ask a question, I'll get the answer, and that'll make me think of another question. I'll get that answer, and then I'll get another question. But by the time I'm implementing the code, I start to forget some of those details. Well, by documenting precisely what the problem statement is on the whiteboard, you will have a word-for-word description direct from the interviewer's mouth to document on the whiteboard, so that later on, as you're qualifying the requirements and working through the design and analysis and doing your implementation, you'll have a direct place to go to that's documented that says exactly what the manager said to you. Now, I used to see with candidates that even when I would tell them exactly what the problem was, for instance, remove the duplicate integers from an array of integers, sometimes they'd write on the whiteboard, remove the duplicate integers from a collection. Well, what's happened is they've already started to morph the problem. They've already started to alter and change what the original problem statement was. And this isn't a good thing. It's a really important thing that you document exactly what the manager has said, because there will be constraints that are declared in the original problem statement, which will provide you the grounds for clarifying additional questions for the attributes, for the constraints that are unsaid in the problem statement. I've seen managers, or at least I've been told by candidates, when they use the whiteboard development environment to write the problem statement on the whiteboard, the candidate gets on the whiteboard, they start to write up, okay, so remove duplicate integers from, and then the manager will interrupt them and say, you know what, why don't you why don't you remove every third integer from an array of integers? And so they start to write, remove every third integer, and then the manager goes, you know what, why don't you instead, why don't you just search for a node in a binary tree? And so what's funny about this is the whiteboard development environment is already delivering on its promise to improve the communication between the candidate and the manager. Because just like in projects, sometimes the feature requirements drift and you get feature creep, and this, by documenting the the actual problem statement on the whiteboard, it can help set the stage as a contract between you and the manager about what's about to be implemented. It's pretty surprising. I didn't expect that when the candidate came back with that, but it's a nice added value. So managers, they're not expecting you to juggle everything in your head. It doesn't impress them that you can solve a problem without having anything documented. You want to have documented what's been said so far, so that you can have a conversation about what's been said. Use the whiteboard development environment to organize your thoughts. It will help you focus on the goal. And you'll find it very valuable to be able to refer back to whatever you've qualified so far when you have a panic moment or you have a brain freeze and all of a sudden you forget what the question was. Well, the nice thing is it's on the whiteboard. You can just turn to it and settle down and know that you can move forward without any more additional anxiety. Now, just like in the real world, systems are too big and complex to fully conceptualize at once in your mind. In the interview, the added stress of the process of being interviewed is going to reduce your ability to retain the details. The whiteboard development environment is going to assist you with that and will provide structure, and you'll be able to lean on it. It becomes your development environment as if you had an IDE. I love this thing, and I'm going to continue to enjoy sharing with you the rest of the features. So, document everything. Use it to refer back to what you've already qualified. So, let's take a look at the structure of the whiteboard development environment. As you can see, we have the problem statement along the top, followed by 3 columns. The left column has 2 rows. The top row is requirements gathering. This is going to be the section where you document the answers to the questions that you ask to clarify the unsaid requirements. Now, the next box in the row below is the design and analysis area. Now, this is the place where you draw pictures. You might actually even label and create variables that represent your pointers and your references to positions within the collection. That is, if you're operating on a collection of some kind. Chances are you will be. But this is for pictures. This is where you describe how the algorithm is going to work, how it's going to move through the collection, and it'll help you realize what the local variables are that you'll need when it comes to implementation. Now, one last thing about the design and analysis. This is where you will describe the big O performance of the algorithm. You need to be able to talk about what the complexity of your implementation will be, and this is when you do it. Now, the middle section, the pseudocode and implementation, this is important because it represents the largest area in the WDE. And the good thing is, pseudocode is your friend. You need to become comfortable writing the pseudocode that will explain the logic of your final implementation. Now, some candidates think, well, I'm supposed to write it in C++ or C# or Swift or Objective-C or Java. But in reality, it's the pseudocode which is going to describe the behavior and the functionality of your algorithm. If you do pseudocode first, you're going to get the benefit of, well, if you end up running out of time, let's say that it's a second or third coding question that you've gotten in the interview and you're near the end of the interview. Well, if you do the pseudocode first and not the implementation, the manager will be able to see that you're on the right track, that you were headed toward the finish line, and that given enough time, you would have finished it. But if you instead you skip doing pseudocode and you go straight to the implementation, there's some costs. One, you might not finish, or let's say in the cases when you do not finish your code, there might not be enough to show that you would have successfully crossed the finish line. And second, there's the cost that you weren't able to delay the implementation details until just the right moment. If at any moment when you're working through your algorithm and you had it in pseudocode, you won't have the reluctance to erase your implementation code. No, let me put that another way. If you write the pseudocode on the whiteboard, you will feel more comfortable to change your pseudocode to match what the actual algorithm should be. What I find is candidates who write the implementation down directly want to leave. Well, they want to preserve that code already, and any changes to it will make it difficult. It'll cost them time to verify that the code changes they've made are actually going to work. So, pseudocode is really valuable because you can postpone the implementation until just the right moment when you have your logic fully realized, and you then can commit to the implementation. Now, the third column on the right, the top row, is the test cases. This is where you're going to be documenting the test cases. You want to, based on the type of collection you're going to be operating on and what its attributes and qualities are. This is where you're going to put, if we have this input data, we expect this output data. Or what happens if we have this other input data? For instance, you have a collection. Well, you probably know you'll want to test for the empty collection case. And you'll also want to test for the one element collection case. Point being, listing your test cases in a designated area is going to help you focus on completing this very small project. Now, I want to go back to the requirements gathering phase for just a second, because the time when you're asking and clarifying what the requirements are, if you follow the test-driven design approach, then you can be generating test cases at the same time that you're qualifying the requirements. And if at any time you get stuck and feel like, I can't think of any other questions to ask in the requirements gathering phase, move over to the test cases and come up with some additional test cases. And as you think about those test cases, they might drive additional questions for you to clarify in the requirements gathering. Now, the final section of the WDE in the third column is in the second row. And this is the watch table. This is your debug window. This area will be where you start with initial values that'll be passed into your function. And it'll have a table where you will have columns for every variable that is local to the function. And then you will step through your code line by line, use your finger as an instruction pointer to follow along, and as each statement is executed, you'll update this watch table, this debug window, with the new state. So at any given time, you could just turn away from the whiteboard, have a discussion, come back, and resume your debugging without any loss of state and context. This WDE is really effective. It's going to help you communicate more effectively. It's going to relieve you of the burden of remembering all the details in your head. It's going to provide a platform for you to be able to communicate what your design is, how the algorithm is going to work. It's going to be a great way for you to demonstrate your ability to generate test cases and clarify unsaid requirements. And it's a great way to have almost a fully functional IDE on a whiteboard. It's going to help you, and I look forward to hearing the stories from candidates who have been able to apply this successfully in interviews, and to hear what kind of feedback you'll give. So let's talk about some of the specifics of each of these sections, because I've gone over just the highlights, but I want to cover in more detail. Again, the problem statement. Use it as a contract. By documenting exactly word for word what the problem was, helps to prevent the manager from sliding the requirements to another problem, and helps to keep the two of you on the same page. It's a great way to establish an agreement right off the bat. Use it as a contract. Second, write it down word for word. Don't generalize, don't substitute. Write it down word for word. You can lean on that when it comes time to clarify the unsaid requirements. Use it to avoid the tendency to morph the problem. These are the primary reasons why the Problem statement is there on the whiteboard to help you. Now the next section, requirements gathering. Let's cover this section in detail. It helps you to manage the ambiguity of the problem. You have a place to document the answers to the questions that you get answers to. It helps you to clarify the problem statement and clarify those unsaid requirements. It helps you to prune the possible solutions that you might be choosing from. See, if you take the original problem statement at face value and you don't qualify any unsaid requirements, there might be multiple solutions that are competing in your mind, and you might not know which one is the most appropriate one to go with. Well, by clarifying the unsaid requirements, it'll help you narrow down, of all the possible solutions available, which one you should go with. Next, you want to solve for the specific case. You don't want to solve for the general case. If you don't qualify unsaid requirements, chances are you're going to implement a solution that goes beyond the scope of what was necessary. Use this section to document what you've learned, because at any point when you're doing your implementation, you might actually realize, oh, there's an edge case I didn't think about. You can turn to the manager, ask him to clarify specifically, and you can document this and extend what you know about the problem. And you'll have a central location where all of this information goes. If you didn't use the WDE, typically I just see candidates that they look for a space to write that additional information. And then by the end of the interview, the whiteboard is just a molten mass of text that might not have any structure. But if you use the whiteboard development environment, it's going to provide better structure and it'll demonstrate your effective communication skills. Now, here are some questions that you can ask to clarify the unsaid requirements. First, what are the priorities? Are the priorities that we have space performance, or is the complexity of the algorithm more important? Second, what are the inputs and what are the outputs? What are you being passed by the caller to your function? And how are you going to get the results of that operation back out to the caller? Are you returning a single value from the function, or is the return value from the function for an error code, and instead you are updating a passed-in reference with the updated data? These are good questions to ask. Also, what do we do when we encounter an error? You can clarify, well, what happens if we have an empty collection? How do we notify the caller that this is an error state? Also, clarify how much memory do we have. For the case of counting the number of on bits in a D word, well, there was no way to create a constant time lookup where you just mapped the entire D word to a specific value, because that would take up all the memory in the system. But if you understand what the constraints are and the manager says, don't worry, there's no constraints on memory, then you can move ahead with an implementation that doesn't need to be constrained by that. Next, are we supposed to operate on this data in place? This is a great question, because for the question, remove the duplicate integers from an array of integers, you have to ask some simple questions like, are we allocating a new array where we're going to be depositing the non-duplicate integers and then passing that back? Or do we need to operate on the array in place? And if we're operating it on the array in place, then there's some additional clarifying questions such as, well, what does it mean to remove an integer? Also, you want to ask, what is the order of the collection? Specifically for removing the duplicate integers from an array of integers, if you know, because the manager has told you that the array is ordered, you won't have to spend time sorting that array before you start removing the duplicates. Next, what are the performance goals of the algorithm? Ask the manager what the target's algorithm's complexity should be. Get them to clarify. If there aren't any constraints, choose the easy one and move on. Next, how do we access the collection? Are we just going to be indexing into an array? Are we being passed a pointer to the beginning of a tree and you need to enumerate through the tree and traverse it? Also, how do we know the size of the collection? In this case, removing the duplicate integers from an array of integers, you'll probably need to know what the size of the array is. But then, that's the array. Is that the size of the actual data that's in the array? Yeah, it depends on what language you're using and whether or not you have built-in primitive functions to tell you the count or the number of elements in the array. But the point being that it's good to ask, are we being passed an array that's partially populated with the data that's important? And if it's ordered, is it ordered and compacted? Chances are it would be. And what is the size of the array that's being passed in? Next, clarify what is the maximum size that the collection can be, and what is the minimum size that the collection can be. See, this might change how you approach the problem. If you know, for instance, that you're only going to have 100 elements in the collection, then maybe a brute force solution isn't that bad. But if you're going to have a couple million elements in the collection, then you might need to come up with a more performant solution that is better than linear time. Also, if the collection is sorted, you'll probably need to ask, do we know the order of the collection? These are really good questions. Next, how often might the code run? How robust and secure does it need to be? And we kind of covered this, but again, how fast or efficient does it need to be? And who will be maintaining the code? Of course, this is just an interview, but these are still clarifying questions that you might ask on a real project, because sometimes you just might need to make throwaway code. It just needs to run once and you're going to throw it away. Or sometimes you might be writing code that's going to be in a shared library. Ask, is this function going to be part of a class or a static utility library that's going to be shared among the rest of the team or with external customers? Clarify these details so that you don't have to solve for the general case. Also, who's going to be maintaining the code? That's a good question. It might mean that you need to make sure that the code is clean and appropriate for the audience that's going to be viewing it. Also, does the code need to be thread safe? Sometimes if you have a library and it's not thread safe, then you'll need to make sure to document that. But of course, clarify. Does it need to be thread safe so you can handle setting up critical sections and using the appropriate mutexes and semaphores to track access and to protect access to shared resources? Simple questions, but it's pretty great set of questions. It'll give you a launching point when you go to qualify the unsaid requirements of the coding questions you get. Now the next section, the next area of the whiteboard development environment is the design and analysis section. It's going to help you visualize the problem. And when you are visualizing the problem, use a concrete example. For instance, if you're going to have an array of elements and you're going to remove the duplicate integers from that array, well, draw a couple boxes, put some actual data in that array that represents that specific test case, and set up some little arrows that represent your pointers, your iterators as they're moving through the collection, and use this graphical representation of the algorithm and draw it so that it can help to communicate to the manager precisely what you intend to do. Walk through the algorithm during this stage and give a statement of the expected performance of that algorithm. This is also the opportunity for you to talk about competing solutions that might have different time complexities. And you can settle on which implementation you're going to go with after having the dialogue with the manager. Weigh the advantages and disadvantages of one solution over another during this phase. This purpose of the design and analysis section is to help you pick the right solution. It's pretty powerful. I've even had managers come up to me that I've shared this whiteboard development environment to, that I've shared the interview patterns concepts to, and they were like, hey, I'd really like our team to use this on a daily basis. I'd love it if our employees came in when we had a team discussion and I had to work through a problem with them, if they followed this outline. It's a really effective way to communicate your ideas with another person. It makes it easy to collaborate. Now the middle section, again, the pseudocode. Pseudocode with comments. This is going to be human readable text that describes the operations and the logic of your algorithm. It's going to help you get from the design and analysis phase to the implementation. What I actually do when I'm at this phase is, when I'm talking about the design and analysis phase and describing what the operations of my pointers or my indices or any accumulators, as I'm describing that to the manager with the pictures, I'm actually drawing on the whiteboard the comments or the pseudocode for that operation so that I can implement it when I'm done describing the algorithm. So it helps bridge the gap between the design and analysis phase and the implementation phase. Pseudocode is your friend. Now, one of the other benefits of writing pseudocode is it helps to prevent the need to decompile your actual implementation into the logic that you hoped or expected the code to do. But the problem with this is, if there is an error in your logic or if there is an error in your code, when it comes time to re-examine this to confirm that the implementation you've gone with works, you can use the pseudocode to help keep you on track. And if you read the pseudocode statement and look at the implementation right below it and see that there is a discrepancy between the two, well, you can fix your coding implementation at that point. That is, of course, if the pseudocode does represent the functionality you're going for. But again, pseudocode is your friend because it helps you more quickly communicate and express and refer back to what the logic of your algorithm should be. Next, for the pseudocode, it helps to enable you to refactor your algorithm before committing to the implementation details. And it'll help managers understand the code as the logic so that they don't even need to worry about your implementation details. The two of you can agree, yes, this is the behavior that we're looking for. The next area of the whiteboard development environment, again, the test cases. This is when you write down the test cases. It'll be used when you test your code because you don't want to wait for the manager to ask you to test your code. When you're done with your implementation and you've already have your test cases ready to go, the first thing you should do is like say, okay, I'm done with my implementation. Let's run some test cases through this. You refer to your test cases box, pick one that looks good, run it through your code, and the manager will be excited. I've had candidates come in and they get done with the code and they think, okay, well, I'm done. But they haven't even had the opportunity to debug their code to find that there's actually an error in their code. If you find an error in your code, is that a bad thing? No. Actually, it's a great thing. If you took a test case that discovered a bug in your code as you were debugging it, and then you were able to iterate and fix the issue, this is an excellent sign. It it shows that you're kind of on autopilot when it comes to writing code. This is what you would do in an IDE, and this is what you do on the WDE. Remember, enumerate the common and obvious cases for test cases. For instance, testing for null collections or empty collections and one-element collections. And like I said before, as it relates to the requirements gathering section and the test cases section, apply test-driven development strategies and techniques to help you get some push off of each. If you run out of test cases, go back to requirements gathering. If you run out of questions to qualify, go back to test cases until you feel confident that you have a good set of test cases and requirements to know exactly what it is that you need to implement. Here are some common test cases that you can remember to put in your test case section. The empty collection, a one-element collection, a greater than one element collection, sorted collection, unsorted collection, item found, item not found, and a void pointer. These are kind of common and pretty simplistic, but heck, if you picked a couple of those and ran them through your code to test it, and your code worked beautifully, that's a really good sign. Now, the last area of the whiteboard development environment, specifically the debug window, is going to help you keep track of state. It's going to help you identify the passed-in parameters and keep track of the values as they change in the local variable state. Use your finger as an instruction pointer. When you are debugging it, put your finger on the whiteboard, update the state, move your instruction pointer. Keep it pretty straightforward. You don't have to just wave your hands. Like, just put your finger up there, use it as an instruction pointer. It's really important. Next, evaluate the assignments and the comparisons by looking at your debug window at, basically you're using this as a state machine, right? So as you're updating the state of each one of your local variables, you'll be able to, using your finger instruction pointer, evaluate any of the switches, the for loops, the ifs, the whiles, to make sure that you're iterating enough times based on the current state of those values. Use that debug window to take all the difficulty out of keeping it in your head. And like I said, finding bugs in your code is a good sign. It's a great moment when a candidate recognizes, oh yeah, I have an error, and that they found it with a test case that they put up there, and they didn't even need the manager to prompt them for it. Well, that completes this section, the whiteboard development environment. I hope you've enjoyed it. I think you're really going to find that being able to use the whiteboard in a more comprehensive way is going to help you communicate better in an interview. In the next section, we are covering the phone interview. I look forward to telling you some of my horror stories of what not to do when doing a phone interview. You might be surprised.